Hello everyone, we're going to continue with the linear regression example and try to predict the house prices from the features that we've already pre-processed. And for that purpose I'm going to show you what linear regression actually is, and later we're going to implement simple linear regression and then multiple linear regression in TensorFlow.js. Okay, so what is linear regression? Linear regression is a model that simply draws a straight line between some data points. In this example, I'm showing you the relationship between the living area of the house and its price. And as you can see, a straight line defined by this equation right here, which is the b times x plus a. And I'm going to tell you about those parameters in a bit. Defines a straight line which is used to make prediction about the prices for a house. So in this example right here, if I go to the 2K living area or the 2000 square feet living area, the expected price of the house is right about 220k USD. Okay, so as you can see, the linear regression is pretty simple. And it is defined by these two parameters, b, which is also known as the slope parameter, or it controls how the angle between the x in here and the line that you're trying to draw. And the other parameter is a, which controls where this line is dividing the y-axis in here. So the purpose of our model, or for the purpose of TensorFlow, is going to be to find those two parameters in a way that they best describe this relationship between the living area and the price. Okay, so that's the case for the simple linear regression, when you have more than one variable that you are going to use as a feature. You have multiple linear regression, and the multiple linear regression is really quite a simple expansion of the idea of the simple linear regression. You just put more parameters like b, and in here we're going to call them w. So those will be the weights or the parameters that we use for the regression model. And in here you have more features, so you have a vector of features and a vector of parameters, but the overall idea is the same. Okay, so as in all of our models, we're going to need a loss function, something that is going to measure how good our predictions are, and based on that the model should be improved. So in our case we're going to use the root mean squared error, which is defined as such, and this error is going to measure how far our predictions are from the real prices of the house, no matter if the value is below the actual price or above the actual price. That is taken care of the squaring of this function, and we're just taking the root of that. This is a standard metric for diagnosing and evaluating regression models. So you might want to check out a bit more about the root mean squared error in the linked article in here. Okay, so let's start by implementing the simple linear regression model in TensorFlow. For that purpose, I'm going to define a function called train linear model, and we're continuing where we left off last time. So I'm going to define this function in here. Or so this is the function. Let me clear that and start over. Okay, so train linear model, and it's going to be an async function. It's going to accept the training data from the features and the labels. And in here I'm going to define our first model. To do that I'm going to use TensorFlow sequential model. So let's define the model. on that model I'm going to use the add method to add a layer. And in this layer I'm going to put in the input shape of the training data that we have, and this is stored in the shape of the tensor. Remember, the 0th position actually tells us the number of rows in our tensor, and the first position tells us the number of columns in our tensor. And since this is a simple linear regression, we're going to need only one unit, so only one parameter that we are going to learn. Okay, so this is our model. Then we're going to compile the model, and we're going to use an optimizer known as SGD, or that's shorthand for stochastic gradient descent. And we're going to put in warning rate of 0.001. We're going to measure the mean squared error. That's because TensorFlow doesn't provide root mean square error out of the box, so we're going to do some pre-processing to get the root mean squared error. And the last thing I'm going to measure is going to be the mean absolute error, which will tell us how far our predictions are, how far our price predictions are from the real values. And this one is in TF metrics mean absolute error. Okay, so we have a model and we have a compilation of this model. So the next thing that we are going to need to do is actually call the fit methods, which will train the model. And to do that, I'm going to store an array of train walks, and we are going to visualize the error on when we're training, the root mean squared error, and the mean absolute error during training again. So I am going to take reference to the two diffs in our HTML file, and I'm going to use the document API for that. The first diff is having an ID was container, and the next one is going to be the one that contains the accuracy, the chart for the accuracy. If I go to the index.html file, you see that we don't still have those diffs, so I'm going to create them in here. This will be the first one and the second one. So I'm going to just get those IDs in here. Okay, so now that we have the reference to those elements, I'm going to wait for the training to complete, and I'm going to pass in the training data and a couple of options for our training. First, I'm going to set a batch size of 32. I'm going to train for 100 epochs. I'm going to request to shuffle the data, and we are going to split the data into training and validation dataset, and I'm going to use only 10% for validation dataset. The last thing that I'm going to do is use the callbacks property to call on epoch end, and this is going to be an async function which receives the epoch and the walks for this. So in here I'm going to push into the train walks the information for the current epoch, and I'm going to store the root mean squared error, and this is going to be the square root of the was from the walks. Then I'm going to take the validation dataset root mean squared error, and in here I'm going to take the validation loss. So the next thing is going to be the mean absolute error, And here I'm going to take the mean absolute error like this, and the same thing I'm going to do for the validation data set. Okay, so we have the training walks in here, and then I'm going to use tf_vis to show the results. And in the first one I'm going to request the root mean square error and the validation root mean square error, and for the next one I'm going to use the accuracy container, and in here I'm going to use the mean absolute error and the validation mean absolute error. So here we go, we have pretty much everything we need in order to train our model. The last thing I'm going to do is import tf_vis, since I probably don't have it right now. Okay, so yep, here we go, and this looks like it should be working by now. For now I'm going to comment out all of this, and actually I'm going to take this one. No, just a second, guys. Okay, so yep, let me just create a new training data set, and I'm going to call those simple ones, and you'll see why later in the video. And I'm going to ignore the last one, and I'm going to call create datasets with the data. Then with the features, again we are using only a single feature, and it's the greater living area. We don't have any categorical features, so I'm passing in an empty set, and this should create the dataset for the simple training. The next thing I'm going to do is wait for our model to train. And this should show us our model in here, and yes, sure it does, it trains. As you can see, the model accuracy, the root mean squared error is decreasing up until something like 30th epoch or something like that, and it stays in here, and the mean absolute error is stable at right about 50k. Okay, so this is the simple linear model, and the next thing I'm going to do is create a more complex version of this model. So to do that, I'm going to take to comment out the simple version, and I'm going to take those features that we commented out. Okay, and again I am going to call the train linear model, but this time I'm going to go to the train linear model, and in here I'm going to put in the number of units equal to the number of features, since, as you probably recall, multiple linear regression is defined by the number of parameters that we're trying to learn, and the number of parameters is equal to the number of features that we're using for our model. So let's see how our model is learning. Okay, so I recompile and run the example. Let's see how we're doing. and you might guess that we are having an error, and the error suggests that we don't have the correct shape. Recall that we need output that is having only one unit. So to do that, I am going to add another layer in here, and for this layer I'm going to output a single unit, which will be the predicted price. So let's see how our training is going now. And another thing that you might find pretty strange in here is the fact that the model is not showing you any mean absolute error or root mean squared error. To go around this problem, I'm going to use activation function, which I'm going to explain why in the next video that we are going to see about neural networks. And after I make this change, let's see what happens. Okay, so this time we're seeing both errors decreasing up to a point and then staying pretty much constant from there. Okay, so we've trained both of these models, and the next thing that I'm going to show you is training of both models and comparing the results between those two. For that purpose, I've included a function in here called render predictions, which will be included in the source code of this project. But for the purposes of this video, we're going to just use that. And let me just take the predictions from our models and try to compare them. So first, I'm going to extract the true values from the y-test dataset, and I'm going to call the datasync method on that one. Then I'm going to take the predictions from the simple linear model. Simple linear model predictions. I'm going to call the predict method on that one, and I'm going to use the test simple data, and again I'm going to extract the values, and then I'm going to take the predictions from the linear model, which in our case is the regression, the multiple regression itself, and I'm going to call that linear model. And from that, I'm going to predict on the same test set. Okay, so now that we have all of this, I'm going to call render predictions. I'm going to pass in the true values, the predictions from the simple linear model, and the predictions from the linear model itself. Okay, so this should wait for training both of these models. Yep, that should do the trick. This should wait for both of these models to train, and then provide the comparison between the two on the test set that we have. Okay, so I'll pause the video in here, and I'll show you the results. And here are the predictions of our model. I had to do a bit of work to get this working. I had to return the model itself from the train linear model function, and another thing I had to do is add these two diffs in here in the index file. So let's have a look at what the charts are showing us. As you can see, the simple linear regression predictions and the linear regression predictions are pretty much identical. So it really doesn't matter, at least in our case, which of those two models you're going to use. Pretty much both of those are predicting a price of 180k for the house prices. So this is pretty strange, and as you can see, sometimes when you offer, when you build a much more complex model and use more data, it is not necessarily the case that you have a better model. So in this case, you might use the simple linear regression predictions and go on with that. There might be some mistakes that I've made during preparation of this model, so you might have a look and see if there is something wrong with training our model. Otherwise, thank you for watching, and the next time I'm going to show you why and how we use those activation functions and how we use them to build neural networks, and more importantly build deep neural networks for understanding images, text, etc. And we're going to have a look at how to build a deep neural network using TensorFlow.js. Thanks for watching. Please subscribe. Bye bye.